This is going to be more quadratics practice, talking about a quadratic equation. It goes along with worksheet 6-4. First off, let's talk about what is the quadratic parent function. So the quadratic parent function that is y equals x squared. Or you could write it as f of x equals x squared. Well, let's look at that real quickly in the graphing calculator. Let me get that up here. There we go. So let's go in here and put x squared, x, and then the squared button. Now, it's a lot easier when we go to do these comparisons. If you go all the way over here to where it's blinking, see where it's right there, arrow over, press enter one time, and it gives you a darker line. This way, when you press graph, it's going to darken it in. Okay, let's see if I can find my paper again. That's not it. Maybe this is 6-4. There we go. Okay, so there's a linear parent function. This U-shaped thing right here, it's not a U. We call it, we don't say U-shaped thing. It is called a parabola. It's kind of spelled parabola, but it's called a parabola. Now, let's go up here. What happens, what they're asking us now is, what we should have already learned, is if we have an equation, y equals x squared plus 2, okay? We start off with a standard form of y equals ax squared plus bx plus c. And for right now, we're not going to talk about the bx, that term right there. This number right here is going to show you how the parabola shifts up or down. So this last number right here is how the parabola shifts either up or down. The a, which is a number in front of the x squared, this is going to talk about the width. It's going to talk about if it's wide or if it's narrow, and it's also going to talk about the direction, whether it opens upward or downward. Okay, so now let me go back up here. And it says, if the coefficient in front of x squared is a whole number greater than 1, what happens to the parabola? Well, let's look at this. Let's go in here and put in there a whole number greater than 1. Let's go 5x squared, and let's press graph. Well, there's the parent function. Now, there's the next one right here. What is happening to it? It is making it narrower. Now, when it's narrower, what it's actually doing is it's a stretch. I kind of compare it to like if we were pulling a marshmallow. If this parabola, the parent function was a marshmallow, and we pulled it up, it would make it narrower. The reason why it's narrower if it's greater than 1, so for example, I have the coefficient is 5 over 1. So that means from this 0, 0, I'm going up 5 and over 1. Up 5 and over 1. Well, the parent function, that coefficient is just a 1, where you go up 1 and over 1. So in this case, I'm going up more than I am over. That's what's causing it to be narrow. The next one, if the coefficient is a fraction smaller than 1, what happens to the parabola? So if I go in here and go down, and let's make this 1/5. 1 divide 5, x squared, and press graph. Let's look what happens. There's the parent function, and there's the 1/5 x squared. Well, that's because I'm going up 1 and over 5. Up 1 and over 5. I'm going over more. Okay, so up 1 and over 5. That's going to make it wider. Now, we're going to call that a compression. Just like if I went to my parabola and it was a marshmallow and I took this parent function and I squished it together, it would make it fatter. Next, in the table below, y1 and y2 are represented. So in y1, this is x squared minus 2, and y2, this is 3x squared. The first thing says, what is the vertex of y1? Well, let's go and identify. We're trying to find the one that does not have a symmetric partner point. The 2's match up, and then the negative 1's match up. What's in the middle is this right here, which is 0, negative 2. My vertex is 0, negative 2. See, the vertex is the point where the parabola changes direction. So right here, it starts at 2, goes down to negative 1, down to negative 2, and it comes back up to 1 to 2. The axis of symmetry, the line where you fold it in half, it's going to be x equals whatever the x number is of this vertex. So it's x equals 0. The symmetric points have the same y values. Well, to 2, 2, right here, the same y value matches up here, and it is going to be negative 2, 2. What is the vertex for y2? Well, let's look and see. In this case, I have partner points 12 and 12, 3 and 3. The one that is not is 0, 0. Well, that makes sense because this constant right here is plus 0. See right here on the other one, it was minus 2. That's why it was 0, negative 2. So I've got 0, 0 for the vertex of y2. It says, what is the axis of symmetry for y2? It's x equals, it's a vertical line, whatever the x number is of the vertex, so it's 0. Next it says, what is a symmetric point to negative 1, 3? Negative 1, 3, here it is. Match up your y numbers. So I have 1, 3. Next, the first one up here says, when graphed, which of the following functions would appear to be wider than the function 2x squared plus 3? What affects the wideness? The ax squared, it's the number in front of the x squared. So I've got this coefficient is 2. I need a number. What makes it wider? Well, it has to be a number that is smaller than 2. This is exactly the same, so that's not going to work. This is a number that's bigger. The larger the number, the narrower it gets. So it's not C. Well, this one says 1/2. 1/2 goes up 1 and over 2. Up 1 and over 2, so it's going to make it wide. The answer should be D. The next one, number 10, says which of the following functions is the same function as f of x equals 4x squared plus 5 and is shifted down 5 units. If it is shifted down, the only thing that changes is that constant. So I would subtract 5 from it. The coefficient stays the same, so I still have 4x squared. That takes away c. All these other ones have it. And then I have 3 minus 5, which is negative 2. So your answer should be B.